Okay, so let's continue with our next video in our coding exercise series. And in this video, we will solve the problem Queen's Attack 2, which is on the hacker rank. It is in the medium category. So let's read the question. You will be given a square chessboard with one queen and a number of obstacles placed on it. So you have a square chessboard. Square chessboard means like uh, it's like what is square length and width is same, right? And one queen is given at any like a place, and there could be some obstacle. Determine how many square the queen can attack. So we need to return some integer, right? So total number of square the queen can attack. A queen is standing into n cross n chessboard because it is a square chessboard, so whatever is the length, same will be the height, n cross n chessboard. The chessboard rows are numbered from 1 to n. So they said, okay, these are the row 1, 2, 3, 4, 5, 6, 7, 8. And these are the columns 1, 2, 3, 4, 5, 6, 7, 8. And going from bottom to top, if the columns are numbered from 1 to n, left to right, each square is referenced as a tuple RC describing the row and the column. Okay, where the square is located. The queen is standing at position RQCQ. So let's suppose the queen is here. So queen is in which row? Fourth row and fourth column. So which means 4 by 4. In a single move, she can attack any square in any of the 8 direction. Left, right, up, down, and the 4 diagonals. So queen can go up, queen can go down, queen can go left, queen can go right. This diagonal. So 4 diagonal. 1, 2, 3, 4. In the below diagram, the green circles denote all the cells the queen can attack. Right. So these are the obstacles. There can be the obstacle. So if there is an obstacle, so cross is the obstacle. If there is an obstacle, the queen can't move further. So queen can just attack left, right, top, bottom, top left, this top right, top bottom, but not top this direction, right? And you need to return that. Okay. Let's go to the whiteboard because like the question is really easy. It's in the medium category. Writing the code is not a very difficult task, but first you need to understand the logic, because if you once understand the logic, anyone can write the code. So let's uh, so I have created one. Let me hide this. Okay, so I have created this chessboard, right? So here is a queen. So queen can attack in which direction? Queen can attack top. So in this chessboard there is no obstacle. So if there is no obstacle, queen can attack above, queen can attack bottom, queen can attack left, queen can attack right, queen can attack diagonal direction, queen can attack this diagonal direction, queen can attack this diagonal direction, queen can attack this diagonal direction. Right, so this diagonal direction. So let's count how many number of squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 7. So total 27. So total 27 squares. Uh, uh, the output will be 27. So, all right, so 27 squares queen can attack. But how you are going to determine? All right, so basically you need to return 27. So if you have four variables, all right, so one variable have this count, second variable has this count, third variable has this count, fourth variable has this count, fifth variable has this count, sixth, seventh, and eighth. If you have eight variable and you have the count, uh, then you can just sum up all the variables, and that will be our solution. Okay, got it. Now, how you are going to determine? Uh, because you need to. So what I am saying is, you have eight variables. One variable, 2, 3, 4, 5, 6, 7, 8. Because you have total eight directions, right? So you need to count. Uh, because queen can be at any place. One second. So queen can be at any place. Queen can be here. 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 Right. So this heart shape I am denoting as queen. So queen can be here. So let me ignore this obstacle, but queen can be here, right? Okay. So now first you need to determine how, like, you need to count the number of squares queen can attack in all direction, right? So by just looking at the naked eye, you can easily calculate, right? So let's suppose queen is here, right? So queen is here. So you need to let me parallelly go to the code as well, so that it will be easy for you. So what we need to do, we need to return how many squares queen can attack, right? And we know queen can attack top. 1 second. Queen can attack top. Queen can attack bottom. Queen can attack so top, bottom. Queen can attack left. Queen can attack right. Right. Queen can attack top, top left, uh, top left. Queen can attack this top right. Right. Queen can attack bottom left. Queen can attack bottom right. So here as well, right? And this is basically already given in the question. You can see top, left, up, down, and four diagonals, right? So 4 plus 4, 8. Okay. Okay. So now, if by any way, I am able to calculate these these eight variables, what I need to return? I need to just return top plus bottom plus left plus right, right? So I can just return the sum of all the variables, right? Okay. But how you are, because initially you have updated with 0 because you don't know, right? But how you are going to know by using the naked eye? Because first we need to solve the problem using pen and paper. Then as soon as you solve the problem with pen and paper, you can convert into the code. Okay. So you need to tell how many squares queen can attack in a top direction. All right. So let's try to figure it out. So let's suppose our queen is here, right? So how many squares queen can attack? Above, top direction, 1, 2. Okay, which is fine. If it is here, then 2. Let's suppose queen is here. Then how many squares queen can attack? So earlier queen was here, right? So now queen is here. So how many square it can go? It can attack in the top direction. So total 4. Okay. Let's suppose queen is here. All right. So queen was here, right? So let's suppose queen is here. So how many, or maybe better, what I can do is I can create a copy. So if queen is here, 2. If queen is here, 4, right? If queen is here, how many? 1, 2, 3, 4, 5, 6. Okay. So just by looking at the naked eye, anyone can tell if queen is here, it's 1, 2, 3, 4, 5, 6. If queen is here, 2. If queen is here, 1, 2, 3, 4. Okay. But is there any formula? So the answer is yes. If your queen is here, right, which means queen is in the sixth row. So if you do 8 minus 6, you are getting 2. All right. So 8 is the total length of the board and 6 is the row. And we already know the position of the queen, and we already know in which row and in which column it is. So we know the row of the queen, right? 6. So if you do 8 minus 6, we get 2. If queen is here, and if you apply the same formula, uh, queen is in the row this, so 8 minus 2, 6. So 1, 2, 3, 4, 5, 6. Okay, queen is here. So if you apply the same formula, 8 minus 4, 1, 2, 3, 4. Okay. if you can place anywhere. Let's suppose I can place here, right? No, it's same only. Let's suppose I placed here. Right, so it will be just one box, right? So 8 minus 7, 1. So what is the formula? So formula is n. N is the total number of length of the board, and row is the basically the variable here given is r underscore q c underscore q, but basically the row in which queen exists and the column in which queen exists. I just replace the r underscore q c underscore q with the row and column, because I don't like this variable having underscore. It's very complicated for me. If you want to use, you can use that, but doesn't matter. Like you can use r underscore q. If you use r underscore q here, automatically r underscore q will come, right? But I used a row. All right. So because if you see here, it is coming r underscore q c, and is the positional argument, is not a keyword argument. So whatever the position will come here, I am going to accept the here, right? So how you are going to calculate the top number of squares the queen can attack? N minus row, right? So whatever the number of total length, and whatever is the position, n minus row. Got it? Okay. Now let's try. So let me rub this. So you have one formula. So currently I am not putting any obstacle. I am not putting any obstacle. All right. So top is top is done. Top is done because we have the formula n minus one, and we already try with uh, 4 or 5 different position, and we know how we calculate. Okay. What is the next? Next is the bottom. How many square the queen can attack bottom? Okay. So here it's one. Let me put a different position. So here 1, 2, 3, 4, 5. Okay. Let me put here. So 1, 2, 3, 4, 5, 6, 7. Let me put at some other position. All right. So 1, 2, 3. So by looking at the naked eye, anyone can tell. All right. But you need to populate some formula or some kind of logic within the code, right? Okay, is there any formula coming? So the answer is yes, because if it is here, if it is at the second row, it has bottom is 1, which is row minus 1, 2 minus 1, 1. Okay, if it is on the sixth row, then 6 minus 1, 5, 1, 2, 3, 4, 5. It is on the fourth row, then 4 minus 1, 1, 2, 3, 3. If it is the eighth row, then total number of squares the queen can attack in the bottom direction, 8 minus 1, 7. 1, 2, 3, 4, 5, 6, 7. Right. So basically, the bottom formula is whatever the row the queen is minus 1. So whatever the row queen is in the second row. If you subtract 1, then which means the bottom square queen can attack is 1. If the queen is in the sixth row, how many squares queen can attack? 1, 2, 3, 4, 5. So 5. Queen is in the fourth row, 1, 2, 3. Basically, you are subtracting. Queen is in the eighth row, so 8 minus 1, 7. You can calculate. Okay. So that is also done, right? So now you already have uh, these things with you. So two formula you already calculated, right? Okay. Now let's calculate the left. Let's keep the same position. If if queen is here, how many square queen can attack in the left one? Okay. If queen is here, how many square queen can attack? 1, 2, 3. Okay. If queen is here, how many square queen can attack? 1, 2, 3, 4, 5. If queen is here, how many square queen can attack on the left? 1, 2, 3, 4, 5, 6, 7. All right. Is there any formula? So the answer is yes. If the queen is on the second column, if the queen is in the second column, so 2 minus 1, 1. If the queen is in the fourth column, 4 minus 1, 3. If the queen is in the sixth column, 6 minus 1, 1, 2, 3, 4, 5. If queen is in the eighth column, 8 minus 1, 7. So basically, left will be calculated as whatever the column queen exists and minus 1. So whatever the column queen exists, so queen exists in the second column. sorry, if the queen exists in the second column, then on the left hand side it will be 1, because 2 minus 1 1. If the queen exists in the fourth column, it will be 3, because column minus 1 3. Sixth column, then 5. Eighth column, then 7. Okay, now, so you already calculate how many column left. Okay, now what next? So you already have the formula. Okay, now let's calculate the right. How many column queen can attack on the right? Okay, I am taking the same four examples. Right. So if queen is here on the right, 1, 2, 3, 4, 5, 6. Right. Here 1, 2. Here 1, 2, 3, 4. And here the queen cannot attack. Okay. Is there any formula? So the answer is yes. So here is 6. 1, 2, 3, 4, 5, 6, which means 8 minus 2, 6. So total length of the board. So total length of the board n minus the column in which queen exists. N minus column. Okay. Here total length of the board 8, and the column in which queen exists 6. So 8 minus 6 2. Total length of the board 8, column in which queen exists 4. So 8 minus 4 4. Column, so total length of the board 8th, and the column in which queen exists 8. So 8 minus 8 0. So now you have the formula, you have this formula n minus column, right? Okay, now you already calculate uh, this thing as well. You already calculate uh, these parameters, all parameters. Now, okay, let me remove this. Okay, so let me put queen here, because now you have to find, you have to calculate uh, top left. So top left means, so if queen is here, top left means diagonal 1, 2, 3. Right. Now how you are going to calculate, because these formula you have calculated, right? N minus row minus 1, column minus 1, n minus column. By looking at the naked eye, you try multiple combinations and you figure it out. Okay, there is some formula. There is some formula, and you have put that formula, right? Now, similarly, there should be some formula for these four parameters. All right. So if you found these four formulas, now 60 to 70% of the problem is done. All right. So now if queen is here, you need to find the top left. Just forget about the remaining three. We first focus on the top left. Okay, 1, 2, 3. All right. So 1, 2, 3. Okay. So let's see how many on the left. 1, 2, 3. And how many on the right. 1, 2, 3. 1 second. And this is the diagonal. Okay, which is fine. So 3. So which means whatever is in the left, whatever is in the right, sorry, left and the top, uh, same is on the diagonal. Is it the same case? So let's try to figure it out. If if it is here, if it is here, right? If it is here, if the queen is here, how many column it can go on? Right. So 4. It go 4, 1, 2, 3, 4. But here 1, 2, 3, 4, 1, 2, 3, 4. So it's still same. All right. Okay. Let's try something else. So as of now, it looks like whatever is on the whatever is in the left, whatever is in the top, it will be the same as the diagonal, but it will not always be. Let's try different position. Let me put here. Right. Okay. Let me put here. So how many column it can go diagonal? 2. So on the left 2, on the top 3. So basically that formula is not working, which means earlier we were thinking, okay, whatever is on the left, whatever is on the right, so you can pick anyone, right? But here it looks the minimum of left and the minimum of top, right? But because the minimum of left 2, and minimum, sorry, a minimum of these two position. So 2 and 3, what is the minimum? 2, and queen can go 2. But let's try another. So currently we found one formula minimum of, let's try. So let me put here. Right. So queen can attack one, two, three, four, five, six, six position. Right. Okay. One, two, three, four, five, six. One, two, three, four, five, six. So minimum of this, it will automatically come as six only. Let's try some another position. Let me put here. All right. So queen can attack only two position. So one, two, three, four, five, six left, and top is two. So which means minimum of left and minimum of top, which is two, which makes sense. Let me put here. So queen can attack three. Queen can attack three position, right? So one, two, three, four, five, six, seven. Seven on the left, three on the top. So minimum of seven and three is three. So that's why queen can attack three position. So which means how you are going to calculate top left? Minimum of minimum of minimum of top, or you can say minimum of left and minimum of top, then you can calculate the top left. So minimum of top means n minus row. Minimum of left is column minus 1. Right. So now you have the another formula as well. So now let's try the what the next. So next is top right. So let me put queen here. Queen here. So queen can go diagonal 1, 2. Okay, how you are going to calculate? So top is 2, right is 1, 2, 3, 4, 5. So it's the same formula coming, minimum of top and minimum of right this time. So minimum of top means n minus row, and right n minus column, because right is n minus column, right? But will it always be the same? Let's try different positions. So let me put here. Okay, queen can go this two position. So 1, 2, 3, 4, 5. Top is 5, left is 2. So minimum of 5 and 2, 2. So that's what that is the 2. Okay, so let's try uh, another. Let me try another. So here, so queen queen can attack 1, 2, 3. Sorry. Uh, so queen can attack. It will start from here. 1, 2, 3, 4, 5. Right. Okay. So on the left, 1, 2, 3, 4, 5, which is fine. On the right, 5. On the top, 1, 2, 3, 4, 5, 6, 7. So minimum of 7 and 5 is 5, and which will the our answer. So which means this formula seems always working. Okay. Now, what next? You need to calculate the bottom left. Uh, bottom left means this thing. Queen can attack how many positions? So let's try. So let's try same formula, minimum of left and minimum of bottom. Right. So 3 and 3. If it is here, right, if it is here, then it can attack 1, 2, 3, and 1, 2, 3, 4, 5, and 1, 2, 3. So minimum of left and minimum of bottom. So it will be remain same. So minimum of left is column minus 1, and bottom is row minus 1. So minimum of left and minimum so bottom, right? So okay, now what next? Bottom right. So bottom right means queen can attack in this direction, 1, 2, 3, 4. So let's try. So hopefully the formula will remain same. So on the right, 1, 2, 3, 4. On the bottom, 1, 2, 3, 4, 5. So which means minimum of bottom and minimum of right. So minimum of bottom is row minus 1. Right means n minus column. All right. So now you have all the formula in place. All right. So you have all the formula in place. So You can like let's suppose if the question says there is no obstacle, you just need to calculate I can place the queen anywhere. You just need to tell how many square it can attack on top, left, right, or all the directions. So what you can do is you have now all the eight variables. You can just return by sum of all the eight variables, and our problem is completed. All right, but here is one catch. So this is done. Our 50% of the code is ready. All right, now, uh, so let me figure it out. Did I put something wrong? Top left. So top is n minus row, left is column minus one, top right n minus row, right is n minus column, bottom left. Bottom is bottom left. Okay, so did I put something wrong? Left column minus one and row minus one. Okay, bottom right, row minus one, right is n minus column. Yeah, which is fine. Okay, so now we have done that. Now, Now the question says there can be any obstacle. So let's suppose this smiley is an obstacle. All right. So if there is an obstacle, queen can let's suppose there can be any number of obstacle, one, two, three, four. But let's start with the one obstacle. If there is a one obstacle, queen can go here, queen can go here, queen can go here, queen can go here, queen can go here as well, queen can go here as well, queen can go here as well. All right. But here earlier queen was going till here, but now queen can go only till here. So which means whenever you find any obstacle, so let's suppose there is an obstacle and the obstacle is in the top right corner. Obstacle is in the top right corner. So which means you need to update only this variable, right? The remaining variable you don't need to update because there is no obstacle, right? The remaining variable will remain same. The obstacle is in the top right, so you need to just update this variable, and whatever the updated value, and the answer will be remain same, the sum of all the eight variables. So you just need to update that variable. All right, so hopefully you understand this problem. So similarly, let's suppose if the obstacle is here, so you need to only, because if the obstacle is here, let's suppose, right, if the obstacle is here, the remaining like left, right, bottom, all the four directional, you don't need to update those variables. You just need to update the top variable. You just need to update the top variable because earlier we were calculated top variable without obstacle. Now you have the obstacle, so you need to figure it out how many number of squares queen can attack. Like in this case 0, if the obstacle is here, in this case it's 1. All right, if the obstacle is here, in this case it's 2. All right, so you need to first find out where is the obstacle. All right, and it could be any number of obstacles, so you need to check for all the obstacles. All right, because one obstacle can be here and there could be here as well. So in this case two variable will be updated. All right, so top variable will be updated, right variable will be updated, but the remaining variable will remain same. Right. Okay, so now you have all these eight variables. Now you need to update these variables. Let's do one thing. Let's create a dictionary, right? A dictionary with some directions, and I can place all these variables in the dictionary. Like it really doesn't matter. I'm just like putting like this only. It's not mandatory. It's really not mandatory. Comma, comma. Either you can use just a variable, or like whatever you want to do, you can do that, because eight variables doesn't looks uh, good. So let's just put everything in a dictionary. So at the end, what I need to return? Return directions dot values. So direction dot values. What are the direction dot values? So these are the values, and I need to return the sum of all the direction dot values. Right. So this is my answer. So this is step one. What is step one? Step one is calculate all the all the squares without obstacles. Squares queen can attack. Step two, update. Step two is update the directions for each obstacles. Right. Step three, return the sum of all the directions. Because why we need to update? Because the question says there can be obstacle. Currently, till this point, the code is just without obstacle, but there are obstacle as well, right? And we enter, okay, now these are the obstacles. So there could be multiple obstacle, and for all obstacles you have the row and the column, because they should tell us where is the obstacle, right? So what you need to do for for every obstacle, because there could be all obstacle, one obstacle here, another obstacle here as well, so there could be any obstacle. So for each obstacles, for obstacle comma row, obstacle comma column in obstacles, for each obstacle you need to run a loop. All right. Understand? Okay, so now uh, similarly, like earlier we calculate this eight direction, so there could be eight scenarios. What are those eight scenarios? Obstacle can be here, 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 top left, top right, top bottom, like basically all eight directions, right? Okay, so obstacle can be anywhere, but how you are going to know where is the obstacle, right? So let's try that. One second. Okay, so now, so this is done. Now you have to iterate for each and every obstacle, because obstacle there could be multiple obstacle as well. So let me create a couple more. There could be multiple obstacle as well, or maybe two obstacle in the same column or same row, right? So there could be multiple obstacles. Okay, so now you need to iterate for each and every obstacles. So let me move this obstacle outside. Okay, what are the possible combinations? So the obstacle uh, is in the same column, right? Same column is obstacle is here, but if it is in the same column, which means obstacle can be on the top as well, obstacle can be on the bottom. If it is on the top, you need to update the top variable. If it is in the bottom, you need to update the bottom variable, right? Okay, so how you know whether the obstacle is in the same column? All right, how you know? If, because you have the obstacle row and obstacle column, if the column of obstacle is same as the column of queen, then it means it's in the same column. So if obstacle column is equal to the column, this column is basically queen's column, right? If it is like that, which means obstacle is in the same column, right? Okay, so if obstacle column is equal to the this column, it's the same column, but column can be, obstacle can be, just we can't say if it is just in the same column, but whether it is above or whether it's below, because we have two variable, one is for the top, one is for the bottom. You can't just say okay it's the same column, but which which variable you need to update, whether you need to update the top one or whether you need to update the bottom one. Okay, now you need to check whether the obstacle is in the top or whether the obstacle is in the bottom. If the obstacle is in the top, which means this is the row, which means obstacle row is greater than the queen's row. Okay, now let's check. If obstacle row is greater than the queen's row, right? So which means obstacle is on top, right? If obstacle row is greater than, because 7 is greater than 5, obstacle row is greater than queen's row, obstacle is in the row, which means you need to update the top variable, because earlier top is 1 2 3, now it will be 1. So you need to update the top variable. So how you are going to update the top variable? You need to update the top variable. All right, so I am putting 0. We will come with some formula, okay, by which formula you are going to update. But now you need to, you need to update the top variable, because earlier top has 3, now it will be 1. But how it will become 1, we will come later. All right, okay. Else, it can be below. If it is below, then you need to update the bottom. So currently I am putting 0. We are yet to update. So yet to update. All right. So yet to update. All right. Because we are doing step by step. All right. Okay. Now, so this is done. Let me, let me rub this. This is done, right? Okay. Now obstacle can be here as well, right? Which means same row. How you are going to check? If if obstacle row equal to row. Obstacle row means obstacle row is same as the queen's row, which means obstacle can be here and obstacle can be here. But whether you need to update the left variable, whether you need to update the right value or variable, how you are going to know? Okay, so which means obstacle is in the same row. But same row, if you say just row is not a variable. Row is not a variable. In row, it could be left, it could be right, right? So which variable you need to update? So for that, you need to check. Okay, how, when you say it will be obstacle is in the left. If obstacle column is less than the queen's column. So if obstacle column is less than the queen's column, because obstacle column is 2, queen's column is 4, which means obstacle is in the left. If obstacle is in the left, then you need to update the left variable. Yet to update with some formula. Else, obstacle in the right, then you need to update the right variable. Yet to update. Okay, elif. Okay, now, so we already placed the obstacle top. We already said the obstacle bottom. We already done the left. We already done with the right. Now the part is the diagonals. All right. Okay. Let's do the obstacle is in the diagonals. Like when you place in the same column, for same column it could be top and it could be bottom. When you place in the same row, it could be left, it could be right. But when you place on the diagonal can be 4 direction, 1 2 3 4. All right, so it could be any which variable you need to print. You can't just say, oh no, it's diagonal, but there is no such variable called diagonal. You have these 4 variables, so you need to find which variable you need to update, right? Okay, so first you need to, how you are going to find whether the obstacle is in the diagonal, because it could be like that. Obstacle can be here, which is neither on the top, neither on the right, neither on the diagonal. All right, so you need to find whether the obstacle is in the diagonal or not. How you are going to find whether the obstacle is in the diagonal? Okay, so you could see here the obstacle is in the diagonal, right? Obstacle is in the diagonal because queen is here. Earlier queen can attack 3 positions. on the top left, but currently it is attacking one because of this obstacle, because after the obstacle queen can't attack. All right, but how you are going to know whether the obstacle is in the this section now? So there is a some formula. If you find, you know the obstacle row, you know the obstacle column. Obstacle row is 7, obstacle column is 2. You know the queen's row is 5, you know the queen's column, right? Queen's column is 4. Now if you subtract obstacle row with queen's row, so 7 minus 5, 2. And if you subtract obstacle column 2 with queen's column, 4 minus 2, 2. And if both are same, which means it is in the diagonal. And you have to do absolute of obstacle column minus column equal to obstacle row equal to row. If it is like that, which means obstacle is in the diagonal. You can calculate, like I place the obstacle here, right? And here 7 minus 5, because obstacle is here, queen's row is here. 7 minus 5, 2, column, this 2, and this is the fourth column, so 4 minus 2, 2. So it's 2. Now let's try some another position. Let me place obstacle here. All right, so now uh, row is 5 and it's 2. 5 minus 2, 3. This is 7. 7 minus 4, 3. Obstacle column is 7. Queen's column is 4. 7 minus 4 is equal to 3. So still, if it is in the diagonal, let's suppose it's not in the diagonal. Now it's not in the diagonal. Will it become same? So answer is no. So 7 minus 4 is 3, but 5 minus 3 is equal to 2. So if it is not same, then it's not in the diagonal. If it is same, which means it is in the diagonal. Okay. So now you figure it out when it will be in the diagonal. But similarly, when you say same row, there could be two conditions. When you say same column, there could be two conditions. Similarly, when you say diagonal, so there could be four diagonal. Okay, how you are going to calculate four diagonals? How you are going to calculate four diagonals? So let me just focus on the uh, top left. Let me first focus on the top left diagonal, right? Okay, how you are going to know? Now you know there is an obstacle in the diagonal, but whether that obstacle in the top left, top right, bottom left, or bottom right. Okay, so now uh, let's place the obstacle here, top left, right? But how you know whether it's in the top left, right? So if top means the obstacle row should be greater than the queen's row. So which means if obstacle row is greater than the queen's row, and because obstacle, that's why it will be the top now. Why the obstacle will be the top? If the row is top. And column should be less, and the obstacle column less than the queen column. If that will be the case, which means obstacle is in the top left. So if obstacle in the top left, you need to update the top left variable. So top left variable 0, yet to update. We are going to come on this formula, so you don't need to worry. Okay, I'll leave. Okay, so let me rub this. So we're done with that. So now let's say obstacle is on the top right. So how you know obstacle is in the top right? So top means row should be more. So if obstacle row is greater than row, and because 7 is greater than 5, and column should be also greater. So 6 minus 6, and this is 4. So obstacle column should be greater than the queen's column, right? If that will be the case, you need to update the top right, because earlier top right value is 1, 2, 3. Now it should be 1 only. But how you are going to calculate 1, that is a different scenario. But you need to update if there is an obstacle. If there is no obstacle, then you are just going to add all these 8 variables, right? Okay. Now if. So obstacle can be here as well. How you know obstacle is on the bottom? How you know obstacle is in the bottom left? So the row should be less, So if obstacle row should be less than the queen's row, and column should be less as well, and obstacle column should be less than the queen's column, which means directions of bottom left needs to be updated, yet to update. All right, I'll leave. All right, uh, and then right, obstacle can be here. So bottom right. So how you know bottom right? So bottom. If it is in the bottom, row should be always less. Row should be always less. Right means column should be always more. Obstacle column should be greater than the column. Then in this case, you need to update the bottom right variable yet to update. That's it. And finally, you need to return, because now, like, see, earlier you have initialized those variables. Now you have updated those variables for each obstacles, and finally you are just returning the sum of all those variables, right? Okay, so 90% of the problem is solved, right? You just need to, because we are here just putting default zero, you can't put the default zero, right? So you need to calculate with some formula. All right, so let's try to calculate the sum formula. Okay, okay, so let's try to, because currently what we are doing is you are just putting 0 0 0 0 0 because we are yet to come with some formula, right? But the code is ready, just the formula needs to be updated, and that's it. All right, okay, so what will be the formula? So if the obstacle is in the top, because first we need to update this one. Okay, let's figure it out. So if the obstacle is in the top, so earlier without obstacle it is taking 3 1 2 3, right? If there is an obstacle, it is just taking 1, right? So which means how you are going to calculate this one? So this obstacle in the 7th row, this queen is in the 5th row, so 7 minus 5 2, and again minus 1 is 1, but will always be the same. Let's try. If queen is here and obstacle is here, so earlier it is taking 1 2 3 4 5, but if obstacle is there it will just take 1 2 3. So 7 minus 3 4, and again minus 1 then 3. So it looks the formula will be, so obstacle row minus the row minus 1. So that will be the formula. So you need to find, because earlier you are taking till end, right? You are taking till end. That's why you are taking n minus row, n minus row, right? Top. But instead of the n is the board side. N is the board side. Now instead of the n, you have to start from the obstacle. So obstacle minus row. But you can't include the obstacle. So you can't include the obstacle. You have to just subtract minus 1, right? Uh, Also, by just looking from the naked eye, you can figure it out. So because obstacle is here, so 1 2 3, 7 minus 3 4, and because total 1 2 3 4, but you can't include the obstacle. You need to tell how many squares queen can attack. So squares queen can attack is this 1, this 2, and this 3. Only 3 square can attack, so again minus 1, right? Okay, so that is done. We updated that. Now for the bottom, let's try for the bottom. Let me try for the bottom. So let me put some here. So if queen is here, earlier without obstacle it is 1 2 3 4 5 6 7, 7, right? But if obstacle is here, just 2. So earlier it's 7, now 2. So how you are going to calculate? So this is 8, this is 5, because earlier for bottom you are saying row minus 1. So row row minus 1, right? So now row 8, instead of this bottom, you have to subtract this obstacle. So basically, row minus obstacle row. So row is 8, obstacle row is 5. So 8 minus 5, 3. But the answer is 2. So you need to subtract one more. So row minus obstacle row minus 1. Let's try with like, oh, sorry. Let's try with some another case. Let me put queens here and obstacle here. So earlier it's 1, 2, 3, 4. All right. Bottom is 4, but now bottom should be 1. So how you are going to calculate the row 5 minus 3, 2, and again minus 1. Because you can't go till end. You have to find the number of rows between these two. All right. So 5 minus 3, 2. And then again minus 1 because you can't include this obstacle, right? So you have updated this. Now for the left. For the left, you need to update. This one done for the left. So let's say left. So earlier, without this, uh, 1, 2, 3, 4, 5. It's 5, right? 1, 2, 3, 4, 5. But now it should be 2. For the left, the solution was column minus 1. Column minus 1 because 1 column. But it should be 6 minus 3 minus 2. So what you have to do is earlier you were doing column minus 1. So now you can't subtract 1. You have to find the column of obstacle column. Obstacle column. Now you find the obstacle column. So queen's column is 6, obstacle column is 3. So 6 minus 3, 3. But you can't include this queen's column because you need to find the number of columns. Because if you go left, you have to find the number of columns. So how you find the number of columns? Just find the difference of these two columns. Queen's columns, obstacle columns, and subtract 1 because you can't include this obstacle. And then minus 1. All right. You can try any and you can put anywhere. So let me put here. So earlier it's 1, 2, 3. Now it should be 0. So 4 minus 3, 1, and 1 minus 1, 0. All right. Okay. Now you need to update the right as well. All right. So let me put here. And right earlier formula was n minus column, right? So earlier formula was n minus column. Okay. So now how many columns you can go till right? So earlier you were subtracting from n minus column. So earlier what you were doing is n minus column. But now you need to find the number of column between these two. Because earlier you were subtracting, okay, total board till board, how many columns. But you need to find how many columns in between these two. So obstacle column. So instead of the n, obstacle column. So obstacle column is 6. This is for 6 minus 4, 2. But you need to subtract minus 1. All right. You can try any other. So let me put here. So earlier 1, 2, 3, 4, 5, 6, but it should be now 1, 2, 3, 4. So 7 minus 2, 5, and minus 1, 4. So 1, 2, 3, 4, right? Okay, so you have updated this as well. So now let's update the top left. So let me put queen here and okay, let's take some easy one. So here. So earlier queen was attacking 1, 2, 3. Now it should be 1 only. So it should be 1. So how you are going to calculate? So you need to update all this. Okay, for the top left, how you are going to calculate top left? How many rows or columns or square basically? So you have 1. So this is the 7. This is 5 row. So 7 minus 5, 2, and it's 1. Just 1 row, right? Because we know it's already diagonal. So obstacle row minus queen's row minus 1. Right, let's try another because just by one example you can't come with the formula. You need to try with multiple examples because it could be any. So here earlier diagonal 1, 2, 3, 4, 5. All right, let me put queen here. So now it should be 1 2. Earlier it attacked 1 2 3 4 5 columns, but now it's only attack 1 2. So how you are going to calculate? So row, so 6 minus 3 3 and minus 1 2. So looks correct. Okay, now top right. So let me run this. Oh, queen is here. Obstacle is okay. Sorry, obstacle is here. So earlier it was going 1 2 3 4, but now it should be just 1, and it should be 1. So is it 6 minus 4, and or is it just a column? Looks pharma will remain same, so 6 minus 4 2 and minus 1. So obstacle row minus 1. So obstacle row minus 1. Yeah, it looks same, but let's try with some another position, because maybe we were wrong. Let's try. Let me put queen here, and if queen is here, then earlier it can attack 1 2 3 4 5 6, but now it can attack only 3. So 6 minus 2 4 and minus 1 3. So yes, it should be 3 only. So yes, looks correct. Now, so we have updated that as well. Now bottom left. Uh, Bottom left. So queen is here, bottom left, bottom left. So earlier queen can attack 1 2 3, but now only 1. So basically uh, row 5 minus 3 2 minus 1. So row minus obstacle row minus 1, because 5 minus 3 minus 2. Let's try another example, because maybe the formula was wrong. Right, so let me put here, let me put obstacle here. Earlier it can attack 1 2 3 4 5, but now it should be 1 2 3. So 7 minus 3, well, it's on the 3, it's on the 7, 7 minus 3, 4 minus 1 3. So 1 2 3. So the answer is correct. Okay, so now let's try the what was that, bottom right. Let me rub this. So bottom right. So let me put here, let me put here. So earlier it can attack 1 2 3 4, but now only 1. So 5 minus 3 2 minus 1. It will be same. Row minus obstacle row minus 1. Yeah, so we have completed our uh, solution, but is it complete, right, or no? So let's try to figure it out. Now this is not complete. Why this is not complete? A very minute thing is left, because currently you have just go with the one obstacle. You have just gone with the one obstacle, but there could be multiple obstacles. So now let's say I put one obstacle here and I put one obstacle here. All right, I put one obstacle here, but I put one obstacle here. So what will be the answer for the top variable? So the answer will be the for the top variable will be 1. All right, but as per our current code, what you are doing, we are iterating over all the obstacle. We are iterating over all the obstacles, and we found the obstacle on the same column, and we found the obstacle on the top, this first obstacle, and you updated this variable, top variable. You updated this variable with 1, which is correct. You updated this variable with 1. How you updated this variable with 1? Because you find obstacle row. Okay, what is the obstacle row? 6, and 6 minus 4 is 2, and then minus 1. You updated that. You already updated this variable, right? But now, because you are checking for all the obstacles, but now you find this obstacle, right? Now for this obstacle, you are again updating the top variable. So 7 minus 4 is 3 and minus 1 2. So now you are updating with 2, which is wrong, right? Because it should be 1, right? Which is wrong. So what you have to do is, before updating this variable, you will check directions of top, whatever the previous variable. You have to take the minimum, because when the obstacle is here, it's 1. When the obstacle is here, it's 2. But you have to take the minimum, because actual is 1 only, right? So the same thing you need to do for every variable. Directions of bottom, and this similarly for here, because there could be multiple obstacle. If there is only one obstacle, then you don't need to do this. Now minimum of directions of right, minimum of directions of top left, similarly here minimum of directions of top right, similarly minimum of directions of bottom left, similarly here minimum of directions of bottom right, right? So now it's completed, because otherwise for some test cases, I'm not saying for all the test cases, for some test cases your code will not work. Because let's suppose in this case, where you have the two obstacle only, but on the same column. So earlier you are updating top variable with just one, but when you come with this obstacle, because you are iterating for all the obstacle, when you come with this obstacle, you updated the top variable with two, right? So total output is like one greater, right? But which is wrong. So that's it. Let's try to submit. Maybe there is some bug or not. I'm not sure. Let's try to run that. Let's try to run the sample code. Okay, sample test case has been passed. Let's try to submit all the test cases. Okay, there is some bug. Let me try to figure it out. That probably we do some mistake somewhere. Where is the mistake? There should be top left, top right, bottom left, bottom right. There should be some mistake. Let me try to figure it out, and we'll come back to you. Okay, one small mistake you could see, instead of subtracting, I just put double equal to. You need to put minus. So let me try to submit the code again. Yeah, now all the test cases are good. That was very silly mistake which we do during the typing. So that's it. That's the end of the video. So you could see the question is like, writing the code is really not tough, to be honest. Like, you are not using any such complicated normal dictionary, normal for loop, normal if else condition, right? Normal return statements. But the main thing is how you are going to like find the solution. So always first try with pen and paper, okay, because you need to return the sum of all the variables. So there should be some 8 variables. Okay, let me try. There is no obstacle. How you are going to calculate? Okay, whether calculate user n minus row, a column minus row, something like that. So you update that variable. Okay, if there is an obstacle, how you are going to calculate that? Okay, if there's a multiple obstacle, how you are going to do that? So we solve this problem using iteratively way. And that's it. You can also try that. So thank you for watching the video.